Hey, hello everybody. Today, a hopefully quick video about, well, I am once again here trying to convince you that digital computers cannot be conscious. Well, hopefully in a very summarized and compact, succinct way this time. If you want to see kind of like further arguments, of course, there's longer videos you can watch in this channel or at QRI. We talk about this quite a bit, but okay, so here is kind of like a relatively new angle for you to take into account. My claim is that digital simulations aren't actually capable of sentience. And this is even if you were to grant that the causal structure of a mind is what gives rise to its consciousness, which I don't even think it's the case. But, first of all, I will argue that the simulation of a physical system doesn't actually have the causal structure of that physical system. It only seems like it does from a certain point of view. And if you interpret, the input and output in the right way. But actually, that interpretation is in your mind. It's not actually out there. I mean, think about it. If you're simulating a field, there's a lot of, computational computational electromagnetism that's, very well researched thing. What you're doing is you're selecting points in the field, and then you're evaluating their values by taking into account their neighboring points, both in the electric and magnetic fields, and using Maxwell's equations in order to update all of these values. And so, statistically, you're discretizing the field, and you're slowly updating it. There's one way you can kind of like squint your eyes and say, yes, inside the machine, there is, implicitly sort of the causal structure of the field, at least, to the extent that the field was doing a particular computation that you were employing before. If the simulation, gives rise to the same computation, you might say, okay, at least from the point of view of that computation, the causal structure was the same. All of these, kind of like culminates on what I would call, a very, very important argument and thought experiment by David Chalmers, dancing qualia. Essentially what he postulates is, okay, if you look at a brain that is presumably, generating states of consciousness, and you actually break it down into its causal structure in terms of a directed acyclic graph, or maybe some other, representation, but like, some mathematical representation that captures how everything is connected in terms of, probability of one event leading to another. And you get at a high enough granularity that it's actually capable of essentially predicting what the person is going to say. You get this very funny situation that if you were saying that, hey, the actual material composition mattered for consciousness, all of a sudden you will have this causal structure, this simulation, telling you, yes, of course I am conscious, I have a visual field, they can tell you details about the visual field, and yet actually not be conscious, right? And there's something really strange about that, which actually would suggest that consciousness is in the causal structure, right? You're probing the causal structure and he's telling you, yes, of course I have a visual field. Here it is. And I can tell you information about it. Because yes, of course, if you're able to say something about your consciousness, about your state of consciousness, it must be part of the causal structure that led you to actually, move your lips and in that way. Well, here's the thing. It is definitely unclear if that is something that you can really do to reality without losing something essential. In particular, the moment you're discretizing the field, you're actually losing the information about the intermediate points between the field. Of course, you could then say, well, let's make the simulation more accurate. Let's simulate more points in the field. And maybe you can say, oh, let's go all the way down to the Planck constant or something like that, so that you're really simulating everything that is going on in the field, as it were. Well, even then, right, for you to kind of reconstruct the causal structure of the field based off of that simulation, you need to interpret it in a very specific, human way. And it's not actually what is truly happening in there, in the hardware. Like if you were to trace how each of the dots in the simulated field is quote unquote causally influencing every other dot, you will see that there is a very big rerouting that goes through, a lot of other transistors, a lot of processes where the interaction is not direct. And so actually you have a very complicated, strange causal structure that you could argue, out of which you could factorize the actual causal structure of the field if you were to conveniently disregard, a lot of these intermediate steps in between. Which takes us to the question, who is it, in reality, out there, who's actually integrating this information? How is that information actually being put together into a unified experience in a way that it knows, how to disregard the intermediate, rerouting that happened in between the points in the field? Well, the answer is that as far as we know, there's nobody there. And even if there was somebody there, that factorization would actually be epiphenomenal. So it wouldn't actually have any effect. This takes me to, this overall point, which is that, in fact, any computationalist or functionalist theory of consciousness ultimately comes to a stop. It collides with a big wall, which is when you ask the question, who is integrating the information that is relevant for this particular conscious experience? It's almost as if there was a godlike observer, that was looking at the system and drawing the boundaries based on, your particular definitions of causality. I don't think that is actually going on. Whatever division there is that separates my experience from your experience must be something that is, objective, frame invariant, real, and causally significant. And there aren't that many processes or physical phenomena that actually satisfy all of those constraints. I will also say that the idea that, yes, if you simulate a field, it will be the field. If consciousness is a field, okay, sure, you will be supposedly generating the consciousness as well. Something that makes this very intuitive is, this idea of, computational physics. That, okay, well, but ultimately, isn't everything just a gigantic causal structure anyway? Like if you go to kind of, the Wolfram conception of physics, reality is a gigantic cellular automata. Well, not really, because the cellular automata that actually are promising for simulating actual, fundamental physics are pretty strange. They're not just regular graphs. They are really complex hypergraphs. And all of a sudden, I think, if you think in this way, you will find yourself arriving at the conclusion that you again need some kind of godlike observer that can sort of look at large regions of these evolving cellular automata and see them simultaneously, in some sense, implicitly already solving the binding problem in that way, or rather executing binding, not necessarily solving it, but executing it. Looking at all of that, information, the state of the cellular automata, and say, aha, here is where this rule might apply, and then update the cellular automata that way. So there is some kind of implicit, godlike omniscience that is kind of doing the computation under the hood. And then if you look at really irreducible, physical phenomena, like large-scale quantum coherence, you will need special rules in the cellular automata to be able to deal with that. Instead, I think a much more elegant way of thinking about reality is very, very strange, but I think much more plausible, is computational holism, where no, it's not that there is this predefined kind of discrete set of rules that are being, are updating this big graph. It's more that there are these universal principles, such as the minimization of energy, or the finding of extremes, as in quantum electrodynamics. And that is the principle that is operating. And that actually, would scale. You don't need special rules for when the system becomes very complex. You apply the exact same principle all over the place, at every scale, at every point in space-time, and things work out. So in addition to this, I will also mention that, okay, if you have this kind of computational holism, then the binding problem may, fall out of the math automatically. When you have a high enough degree of certain kinds of coherence or integration, or in QRI's case, a topological boundary, then, principles of energy minimization may apply only within, the pocket of coherence or integration, or the topological pocket. And so, actual kind of like unified behavior arises naturally. Not something you can easily, bootstrap out of something like a gigantic cellular automata. Okay, the last thing I will say is that I think actually the very concept of causality as your grounding for consciousness is very dubious. And that is because causality, well, there's a strong version of causality, which is the idea that, like, no, truly there is some kind of what I call contact in basement reality, like real deep interactions between the elements of reality, direct interactions, versus a soft version of causality, which is defined exclusively in terms of networks of conditional probability, meaning that, the probability of a particular event happening, conditioning by other events is such and such. You can infer causality based on those networks. The work of Judea Pearl is really relevant for these. For example, the the Book of Why explains all of these concepts. And that is, kind of a, reductionist, deflationary account of causality. That, okay, like maybe really there is no contact underneath. There's just, statistical patterns. And that's all there is to causality. But if you have that notion of causality, you are in deep trouble when it comes to things such as understanding or solving the binding problem. Why? Because understanding what computation a system performed under this, weak notion of causality, you actually need to take into account not only what the system did, you also need to take into account what the system could have done at every point in its execution. And that is because causality here is defined probabilistically, right? It's not only, hey, what happened, but it's like what happened with what probability under what circumstances. Meaning that the true nature of the causal structure is not actually realized on any one run. You need to run it a bunch of times and then get the distribution. And then you will get, if you integrate all of that happen, you will be able to get, or reverse engineer the underlying causal structure. But otherwise, in some sense, the causal structure was not, quote unquote, realized, right? It's something that only exists when you do a bunch of runs. And so if you define the computation in terms of causal structures in this weak variant, then you again need a kind of godlike observer to look at the system and be able to interpret not only what the system did, but also what it could have done, and somehow take all of those counterfactuals, that huge network of, alternative worlds that could have been, and sort of integrate all of those counterfactuals and put them in some kind of unified information representation and essentialize it and say, okay, this is what happened, And I think that, it requires a godlike observer that is actually epiphenomenal, is not doing any additional work. And it requires, some kind of like omniscience, the ability to see large swaths, not only of what happened, but also what could have happened, which to me really is nonsensical. I think a much more plausible scenario is that there is actually something truly, truly deep going on in causality, which I'm talking as contact. And that is that, if you think of reality as, like a network of soap bubbles, different topological pockets whose boundaries shift. Sometimes there is topological fusion when, you could imagine the boundary separating two soap bubbles like pops, as it were, would be a very simple example. Well, then actually there is contact underneath, right? Like this bubble is actually touching this other bubble. They may, equalize their energy or their momentum or their curl or divergence, all of these differential properties can be equalized as the elements of reality touch one another. And that these like touching is real. There's actually something real that corresponds to these contact. And I think that is the case because with that, you can actually arrive at non-trivial structures that map onto bound states of consciousness, where you don't require this kind of omniscient, godlike observer to look at a system and compute all of its possible counterfactuals and then overlay on top of that an interpretation of what the system is computing. None of that is needed if you have this like strong, interpretation of causality that actually uses kind of like contact underneath the hood. And I think that's much more plausible, in which case, reproducing the network of conditional probability around a contact event is not actually replicating the contact event at all. The contact is happening in the field, but is not happening in the simulation of the field. And that is why, if you were to make a digital simulation of a human brain, including the electromagnetic field, and somehow you were to be able to take into account all of the runtime complexity, finicky problems that are involved in doing that, you would actually not get a conscious result. All right, hopefully that made some sense. Until next time, infinite bliss, everybody. Ciao.